हेलो स्टूडेंट, आज की वीडियो लेक्चर में हम बात करेंगे सोल्युबिलिटी प्रोडक्ट की। नाउ व्हाट इज सोल्युबिलिटी प्रोडक्ट। सोल्युबिलिटी प्रोडक्ट करने के लिए हमें एक एग्जांपल कंसिडर करना है AgCl। AgCl इज अ sparingly soluble salt. This is the dissociation reaction of the sparingly soluble salt. AgCl dissociate into Ag plus and Cl minus ion. As it is a sparingly soluble salt, it is dissociated in a very less extent, means maximum portion is undissolved solid AgCl. Whatever the portion is dissolved, that completely dissociates into the Ag plus and Cl minus ions, as AgCl is a strong electrolyte. Very soon dynamic equilibrium is reached. At dynamic equilibrium, undissolved solid AgCl concentration is equal to the dissolved ion concentration. Okay, so we can write the expression for the equilibrium constant. As we know, the equilibrium constant K is equal to concentration of product upon concentration of reactant. As this is reactant and reactant is solid, so we can take the concentration of undissolved solid as a constant. So for this we can introduce a new constant K dash. For the concentration of AgCl we introduce K dash. Now equation becomes K dash is equal to concentration of Ag plus into concentration of Cl minus. So the K dash is called as the solubility product, and we can write Ksp for that, and Ksp is equal to Ag plus ion concentration and Cl minus ion concentration. So the definition of the solubility product become product of concentration of the ions in saturated solution. Okay, so we can write Ksp for the saturated solution only, and in the next topic we will very soon understood what is saturated solution. Okay, the now Ksp is called as the solubility product, and it is a kind of a equilibrium. It is a kind of a equilibrium constant. Okay, so general salt solubility equilibrium. General salt solubility equilibrium expression is, suppose this is a general equation Bx giving x times By plus y times A x minus. So the solubility product we can write Ksp is equal to concentration of this ion raised to the power its coefficient into concentration of Ax minus raised to the power its coefficient. Therefore Ksp, the solubility product, is the product of concentration of constituent ions raised to the power equal to their respective coefficient at the given temperature. Okay, so this is the solubility product, and here the key point you should keep in mind: Ksp is a fixed value and it is only for the saturated solution. More the Ksp, more the dissolution. Okay, so Ksp is the fixed value. क्यों है Ksp इसलिए फिक्स्ड है क्योंकि ये सैचुरेटेड सॉल्यूशन के लिए होती है, and it is only for the saturated solution, and more the Ksp, more the dissolution. Okay, now consider one more example. For example, let's take the example of CaF2 to calculate the Sp. CaF2 is also a sparingly soluble salt. For this dissociation reaction is CaF2 giving Ca2 plus 2 minus ion, 2F minus ions. With very soon dynamic equilibrium condition is reached, and CaF2 dissociate into Ca2 plus 2F minus ions. At this equilibrium, Ca2 plus minus ion and 2F minus ions concentration is highest, and this is the saturated solution. At equilibrium in saturated solution has maximum ion concentration, and it is the constant value, and the saturated solution means no further solute is dissolved in the solvent. Now we can write Ksp for the above dissociation. Ksp is equal to concentration of Ca2 plus into concentration of F minus raised to the power 2. The Ca2 plus and A2F minus ion concentration is maximum at equilibrium in saturated solution. Okay, so we can say that for a particular salt Ksp is a fixed value and it is the temperature dependent, and Ksp is for saturated solution only, and Ksp is about the maximum of number of ions that solution can hold. Okay student, thank you.